is Simon Camponuri. He will be talking about forecasting the impact of hydroclimatic swings on coccidioidomycosis incidence in California.
Hi, everyone. Thank you all for sticking around for the last session. And I just want to take a moment to thank the organizers for the opportunity and for putting together another fantastic meeting. I know it's a huge highlight for our research group to come here every year. My name is Simon Camponuri, and today I'm going to be talking about some of our group's research forecasting incidence of valley fever in California in response to recent hydroclimatic swings. But first, while this work was done in collaboration with CDPH, the findings here don't necessarily represent the views of CDPH or CHHS. So not to beat home this point, but in California, most of the cases are reported from the southern San Joaquin Valley, but we're starting to see more and more cases reported in the northern San Joaquin Valley, as well as along the central and southern coast. And the disease is of increasing concern because cases have increased pretty dramatically over the past 20 years, with a 600% increase between 2001 and 2023. And thanks to work from a lot of the people in this room, we know that climate plays a pretty key role in this increase in expansion and has led to a lot of great news coverage bringing attention to this disease. In particular, prior work from our group has found that valley fever is a climate-sensitive disease, and particularly it responds to these hydroclimate swings, so very rapid and large transitions between very dry and very wet conditions. And these swings can occur intra-annually, so between seasons, where we see very wet conditions we think promote growth in the soil, followed by very dry conditions that dry out the soil and promote soil erodibility and aerosolization of arthrochonidia. They can also occur interannually, so between years, and that typically happens when there's very severe droughts that are followed by anomalously heavy precipitation. And we think that influences these upstream factors, including rodents, population abundance, dynamics of soil microbes, and land use change, as well as other biotic and abiotic factors associated with Coccidioides growth. And so our prior work found that in California, an increase of 1 IQR in winter and spring precipitation increased the incidence in the fall by about 45%. And an increase of 1 IQR in summer temperature was associated with about doubling of incidence in the fall. So that grow and blow hypothesis that we talk a lot about. It wouldn't be CSG without somebody saying grow and blow. But these swings can also occur interannually, and our prior work found that during droughts, incidence is suppressed, and so we see fewer cases that would have occurred if there hadn't been a drought. And then when those droughts are followed by very heavy precipitation, we see these big spikes and larger spikes than we would actually see if the drought had not occurred. So after doing all that work, we were happy that we had found these associations, but while we were doing it, there was another big severe drought in California between 2020 and 2022, kind of capping off the driest 22-year period since 800 CE. And this is just a photo of our field site and us sampling out in April 2022. And the US Drought Monitor is on the top here. And so that drought was then followed by very anomalously heavy precipitation in the winter of 2022 and 2023. And this map just shows the percentage of average precipitation during that water year. So the state experienced about 150% average precipitation, but it was even higher percentages in the highly endemic region. And it turned that very arid field site into this kind of wildflower wonderland, which was great for us, but not great for valley fever. Spoiler alert. So that raised concern about the possible increase in risk in 2023. And so our partners at CDPH put out a press release warning about a potential increase in incidents during the fall and advising folks on how to prepare and protect themselves. And indeed, we saw a big increase in incidents during the fall of 2023. Shown in the blue box here is that large near record number of cases. But wet conditions continued into the winter of 2023 and 24, and so precipitation was 115% of average statewide. So there was continued concern about a second year of elevated incidence. And so we wondered if we could do better than just telling our state partners, okay, we think it's going to be a high risk year this year, but can we give them something more quantitative, tell them, when and where, and all of these things. When and where we think cases are going to be the highest, when in the year, which regions in particular, and then how will this year compare to previous years. And so to do so, we developed an ensemble model, and I don't need to tell you the benefits of an ensemble model because Michelle did more eloquently than I can. But our ensemble included 5 models, 4 generalized linear models with and without interaction terms, and 1 random forest machine learning model. It was trained on census tract level case data, as well as current and lagged environmental data, including temperature and precipitation, as well as indicators for drought. So we used a leave out future year cross-validation approach where we trained our model in these green periods here and then tested how well it performed on the brown periods, adding an additional year each time to see how well our model was predicting cases in the future. So we did that for all 5 of our models, and then to generate our ensemble, we weighted each model output by the inverse of the out-of-sample forecasting error. And then we generated 90% prediction intervals by cluster bootstrapping census tracts, fitting our model again on each of those data sets and then forecasting. And then to add additional noise, we sampled from the observed residual distribution. And then we took the 5th and 95th percentile of the resulting distributions to generate this interval. So this is our model fit to the statewide data, which we were fairly happy with. It captured the large spikes that we've seen following drought periods quite well. So we felt comfortable going forward and forecasting for the coming months and years. And this is what we found. So when we use the model to forecast from January 2023 through March 2025. And so following the wet winters in both 2022 and 2023 and the 23-24 winters, we forecasted 2 large spikes in cases in the subsequent fall of 2023 and 2024. So looking a bit closer, we forecasted about 12,000 cases to occur in both the 2023 and 2024 transmission years. So that's between April and March of the following year, which is roughly a 59% increase over the years prior, or over the 2022 case data. And because we did this, built this model at the census tract level, we could produce region-specific forecasts as shown here. And so this allowed us to identify which regions we expect to see the highest number of cases occur in, and when in those specific regions we expected cases to increase. And these, maybe unsurprisingly, are the regions that I mentioned at the beginning: the northern and southern San Joaquin Valley, and the central and southern coasts. And so with that, CDPH released another press release in August of 2024, warning folks about the regions that are expected to see the highest increases and giving them information about how to protect themselves from coccidioides exposure. So how did we do? Well, comparing our forecast to what we observed, our forecast pretty closely matched the increase in 2023, though we did forecast that cases would start to increase slightly earlier than they did, but the magnitude of the increase was pretty well captured by our forecast. And then so far in 2024, I'd say our forecast is capturing the trend in provisional cases even closer. And we have a few more months left until the provisional data is posted for February and March of 2025, but we're on track to fit our prediction for the annual cases in 2024. So putting this work into larger context, droughts are becoming more frequent in the Southwest as rising temperatures more frequently co-occur with precipitation deficits. And at the same time, precipitation in California is expected to become more volatile. So we're expected to see wetter wet conditions and drier dry conditions. So these big swings between extreme dry and extreme wet that we know increase valley fever incidence. So just to sum up, These intra and interannual swings between dry and wet conditions are really important for transmission of valley fever. These big hydroclimate swings in 2023 and 2024 were associated with the high incidence that we've seen in the past few years. Our climate-based forecasting model did a pretty good job at forecasting the incidence that we observed. And as the climate becomes more volatile, these climate-based forecasts and projections are going to have a pretty key role in preparing for changes and generating awareness about when and where we're expected to see cases. So with that, I just want to thank our fantastic team of collaborators, our two primary colleagues in this work, Drs. Jennifer Head and Alexander Heaney, were really instrumental. And I will take any questions.
That's very nice. So a couple of questions. So when we talk about dry years, we're talking about the entire year, but I'm assuming, and I think your model says, because cases occur usually in the fall in California after so that's when we're still seeing that seasonality, that even though we have a wet year, in California, that's a wet winter.
Right.
And then
right.
we're seeing the increases. So that's what's happening. The second, could you apply that model, or would you have to do other analyses, say for what we call Arizona uplands, like Phoenix to Tucson, to model, because the San Joaquin Valley is a very different climate and geography than Arizona. So it'd be interesting to see how the model works for a different area.
Yeah, great questions. Thanks, Neil. I think definitely it could be applied. Obviously, we know that the climate dynamics in Arizona are quite different than California, and so the associations between drought and temperature and precipitation are also different. Those should be captured in the model. We haven't done it yet, so we don't know what those associations are, but presumably it could be done. I can't guarantee it would be as accurate. I don't know yet, but yeah, we're hoping to continue to improve the model and expand the work, and hopefully across states as well.
I was curious about the decision process for the public release by CDPH of these risks. So communicating risk has always been very difficult, and they have to translate the science that you did and your 95% confidence intervals, make them comfortable to then have a public release about risk. And so with those discussions, how tight were your intervals to give them comfort for their risks analysis, to translate those risks to the public?
Yeah, it's a great question. I may defer that to our CDPH colleagues because they're the ones who are putting out the release, but we've been working with them for 7, maybe more years now. And all of the work that I presented at the beginning was done in collaboration with them as well. And so these associations with climate, they're very aware of, and it has been a process to tailor the public messaging to fit the science, but also what the
Well,
state
especially
feels.
if in this particular model you have regional models, and if your confidence intervals are really wide in the southern San Joaquin Valley, you're like, maybe we better not put alert there. But because they're tight in this other part of the model and it's increased, we're okay with that.
Right. Yeah. And the thing with a forecast is it's probably going to be wrong. Yeah. And when I don't work at the state public health department, but you don't want to put out something that is wrong.
I think Gail is probably, we should query Gail. She certainly asked a question, so she's probably online.
We wish you were here, Gail. But yeah, great question.
I just might mention that my colleagues at ASU in their decision theater had a poster up last night about modeling using environmental and weather characteristics for Maricopa County. And that was just published in Lancet Americas. So I think the idea is that I think there's every reason to think that we can have predictive models in Arizona as well as for California. I think it's great work.
Yeah, thank you. I was looking at that poster, and it looked like it was on a shorter time scale, like 10 to 30 day forecasting. The work here is months to years, which hopefully we could do for Arizona as well.
Thank you very much.
Cool. Thank
Wonderful
you.
talk.